All right, 1.7, technology and calculus. Should I talk like this the whole time? Make me sound really funny. Okay, Corey, what are the 4 things you can do on the AP test on a calculator and get credit for it?
You can. It's not a lot.
There are 4, actually, like I said.
I know, there's 4, but they don't ever help.
Okay, you can graph in a viewing window. Number 1.
In a viewing window?
Yeah.
You can't zoom in or like...
Oh, yes, you can. It's a viewing window, not 1.
Oh!
Next.
Can I say on
Say something.
that? See, you cheaters. Numerically calculate the value of a definite integral.
Okay.
I have all 4 of them.
Get all their
Okay, so next one.
Just a minute.
What does that mean?
You'll learn what that means, okay? What else?
Numerically calculate the derivative of a function.
I was going to say derivative, but I thought you couldn't.
Okay. And?
Why is there 5 zeros, Steve?
Yep.
And calculate the integral.
So what you know how to do right now is the first 2. Okay, you know how to do zeros and graph in a window.
I know how to do all.
The first semester you'll learn what a derivative is, and second semester you'll learn what an integral is. Okay, so that's what's coming. My point in telling you this is to say that you can't use your calculator for very much heavy-duty calculus on the test. You have to show a lot of work in algebra, so you might want to get used to doing that. Okay, so I'm going to be a tyrant about your algebra skills and showing your work. No work, no credit. Yep, I know. Try doing that in the job. No.
Oh.
It does too much. I'll look it up to make sure, but I don't think you can. Okay, so let's look at... Okay, your y equals screen. Type in x to the 9th. Minus 20x plus 1. Oop, that's not the right one. Dude, come on. I hate these calculators. I did.
No, I was talking to you.
Okay, I'm going to show you some ways to manipulate the window. Okay, is that very useful? No. How do I get the standard viewing window? Zoom 6.
Zoom 0.
Zoom 6 gives you zoom standard.
Zoom 0. Zoom 6.
How many roots or zeros does this have?
Let me see. Like 0.
How do you know that?
There we go.
Or you can just go
How can we make it more friendly? So it stretches really high, correct? So let's change our window to, let's say our y max and min 100 and negative 100. And regraph it. Ooh, that's easier. I'm going to change my scale to, no smoking marijuana in calculus, sorry. Now I can also adjust the x's. Let's try a -2 and 2. All right, so we get approximate zeros, right? Do you guys know how to calculate those zeros on your calculator?
Yeah.
Go ahead and do it. If you do not know, it's second calc 0 left bound, right bound, guess, and what do you know? Okay. I'm going to pick on one person from each table.
But hold on, I'm still trying to give up the room.
So,
Your stop.
Wait, what did you put in your window?
That's not where I wanted it.
what I set mine at?
Yeah.
X's -2 to 2.
Whoa.
Okay.
Y's -100 to 100. That means your stat plots are on and you need to, your window needs adjusted.
What should I do?
Go to window,
Yeah.
or sorry, go to zoom. 6, enter. That gives you the standard. Oh, you have the wrong function in. Like this.
I'll write down.
What did you write?
X to the 9th minus 20x.
Why'd you put X to the second?
X to the 9th minus 20x plus 1.
Why did your problem say second?
Yeah.
Yours says
Oh, because I
second.
wrote it?
Wrong?
It makes sense, right?
You wrote it wrong though,
I did.
right?
Yeah.
You did? I had X to the 9th at first, but I thought it was wrong.
Any questions? JT, give me a 0. I don't care. Okay, good. Allie Moore.
A 0?
Yeah,
Which one did you see?
0.05.
Oh, 0.05, that's good. But negative 1.36. I got.
I got 4.
What?
I got -1.
I got that 1.46.
And Josh.
1.448.
I got these 1.46. Oh, never mind. I didn't get 1.6.
Okay.
I got 100.
You can get as specific as you want, but those are approximate, so are we good there?
I need a 1.6.
Okay, we can also calculate some solutions. Being careful here again. Knowing that you have to show some algebra here. Okay, here's how I'm going to solve that equation on the calculator. This is an answer check method. Put cosine and tangent in your y equals. So y equals cosine and y equals tangent. Make sure you're in radians. You best believe it. Ooh, your calculator's working hard.
What is it?
Oh, you're just acting one at a time.
Mr. Arthur, what did you type in?
Okay, my window's off, right? Can't see anything, so Zoom 7 is the trig zoom. Okay? Zoom 6 is the standard window. What in the world? My calculator's confused.
Mr. Arthur, clear your memory, it'll run faster.
Maybe.
Yeah, no.
I just pushed enter on accident.
I don't understand.
That's pretty cool.
Okay, what are the solutions? So now we're going to calculate and intersect. Yep. First curve, second curve, and we get z.
Oh, you're right. Where?
And then you have another one as well.
You did the same one as me, Arthur. Is it 6 to the line above it, or is it 666? Yeah.
Not good.
There's
Not good at all. Not good.
That's a sign.
Whatever that is. That counts for that one. The exercise for that one is going to be exactly.
2.475.
Okay, Arthur.
What? Ha ha. I think I heard that same joke last year.
Wait, what?
Okay. Now, so we have intersects, but we have to figure out all of them. How am I going to write my answer so that every single one of those intersects is accounted for? Like I have this one here is 0.666. How do I note for the next one out here? And the previous one, which is this one here. Is it, how many pies is it away? So it's 2.475. So every 2 pi is when this repeats. So you'd write 0.666 plus 2 pi k. K is an integer. That's how you would write that. K is an element of the integers. It's a z. Not a, okay? Are we good there? Alright, type in your new function. Hello? When you type in these rational functions, make sure you use parentheses. These calculators know order of operations and you'll screw it up. Where is the asymptote? Where are the asymptotes? Yeah, right now it is. People can actually be watching live if they wanted to hear your idiocy and my insults. Our principal is probably watching right now.
Hello to my future self.
That's cute. They're up here.
That was awesome.
I wonder if all our voices are high-pitched and squeaky.
Maybe, I don't know. Okay, based on my viewing window, it was hard to see any asymptotes, but if you change it, it's easier. Okay, if you look at the algebra equation, is there a vertical asymptote? Where?
at x equals 2.
Okay,
Okay, that just means the denominator is 0.
What calculator is putting the asymptotes in the graph?
Oh, very nice.
yeah, older ones do the doors down.
I'm sure you could turn it on or off.
And why not allow to have it on?
You can have it on.
Oh, of course, you can figure that out without even using a calculator.
Yeah, you can.
Yeah. But work hard, smart enough.
Okay, calculus students from last year, how do we figure out horizontal asymptotes? No.
Yeah, this one always got me. I remember.
Limit as x approaches infinity. You guys probably saw this last year.
Divide everything by the highest power of x. Right? That's not how we do it.
Okay, that's how we would do it. It just so happens that it is 3, negative 3. So, aside from limits is chapter 2. If you divide everything by the highest power of x, you get 1 over x minus 3, 1 minus 2 over x. These go to 0, right? Because we're going really big, so in a denominator, and you get negative 3. So, looking at your graph, can you also see where that's true? Okay, you could trace it to get close to 2 and negative 3. Is that enough explanation? Negative 3. You're going to get a heavy dose of that next chapter, so don't worry about understanding it right now. Maybe.
And then you know how one over that representative approach.
Okay, can we move on? Yeah. Okay, there's your next function. Oh, that would be an n. You put x in. What happens as n What happens as n goes to infinity there? What does it approach?
It approaches like 1.
Approaches 0. Right?
No, see, we're going that direction, towards infinity. What y value does it approach? Okay, so try a new window. Let's say 0 on the x min, x max, let's try 3, y min 0, x, y max, let's try 1,000. Because we're going a long ways out, right? Okay. Y, oh, yep, that was dumb. 0 to 1,000 on the x's and 0 to 3 on the y's. Okay, we can now, there we go. X is 0 to 1,000, y is 0 to 3. Okay, trace it and see what you get. What's your y value going towards? Ooh, I'm getting like 2.71. 6 plus, and it keeps going. What number do you think it's approaching?
0.
One.
Let's try a different window. Let's try 10,000. Oh yeah, we're getting big now.
What did you do for the Y minute now? It looks like
0 and 3.
3,000.
Does it keep going up? Oh, 718. 7181. Okay, what was that magic number we looked at yesterday? Pretty much, it's likely to approach E. We can't guarantee it because we didn't do it algebraically, but...
Did that one follow?
Okay, so we would write F approaches E as N approaches infinity. Okay. So if you want to write it mathematically, there you go. F goes to E as N goes to infinity. Okay, and now that's just an educated guess. We can't guarantee it. Algebraically, we could, but...
So you just have to experiment the graphing and
Yeah, we just... Basically what you're doing here is verifying answers after you've got an answer, okay? You guys know how to find minimum, maxima?
yeah.
Do you want me to go through it with you? You have to show your work. On the AP test, you have to show your algebra to find min-max. Do you know why? Because there's a calculus work involved. I will show you how to use calculus to find min-max, and it's super easy.
Okay.
Yeah.
Because I always think it's where I find them, and that's really hard.
Yeah. We'll use the derivative.
Okay.
So, do you guys want me to show you min and max
Yeah.
graphically? Okay, type this in.
Wait, so later, are we going to learn how to do it algebraically using derivatives?
Yep. So 17v to the negative 1 plus 10 to the negative 3 plus v to the 3. I try to make it difficult on purpose. Yeah, it would be x in your calculator. Okay, this is actually a function. It says according to one model of bird flight, the power consumed by a pigeon flying at velocity v in meters per second is p of v. It's burning energy in joules per second. Okay, what's the minimum? The velocity that minimizes power consumption. So we're going to be most efficient. That's interesting. Zoom 0.
Oh, that's weird. That is not what I got.
Whoa, my graph's not right.
Mine looks like this. I got it.
Oh, well, that was dumb of me. I didn't put my X in there. Now let's try it.
What is it supposed to look like?
Okay, it's supposed to look like what mine is.
Oh my gosh. Okay, I got it.
Nope.
I got something really different from everyone else. I'm not sure. Maybe it's the way you type it. Oh, it's just
Do the standard and outlook.
Huh. Something is just not right here.
It's Zoom standard and it might look right.
Hey, Miss Redmond. Instead of remember the best like that here. Instead of remember
Okay. Try this window. You did 40s, right? There we go. That looks better. What we need, so if we're reasoning through this problem, what we need is the minimum power consumption. So we just want this first quadrant because that's a minimum, right? So if you want, you can just change it to 0 and 0. It'll make it easier to get your minimum. Now you can calculate a minimum, and we'll try to find the left of it. The right of it. And we'll guess. $8.6. So all right, so at a velocity of 8.676 meters per second, the bird is consuming 2.612 joules per second of energy. That's what the answer means, which is the most efficient. Alright, that's the most efficient. Yeah, but you're in the negative velocities. Birds don't fly backwards last I checked. I'm sure they can. Okay, are you on board there? Okay, this is the last one, probably one of the more important ones. Is local linearity. The big part of derivative, a derivative is actually a tangent line, which gives us a slope of a graph at a certain point that's not linear. Okay, so we'll have slopes at certain points of graphs that are not linear. This is a way to kind of estimate that slope with your calculator. All right, so basically what we're going to do is put in f of x equals x to the sine x in your viewing window. We choose these ugly, dastardly functions because they illustrate it nicely.
Leave the window the same if you just go through it. Cool.
Oh man, that looks like a sickening roller coaster ride to me. Okay, we're gonna focus in. We're gonna focus in at x equals 1. Okay. So we can zoom in at x equals 1. Oop. Zoom. 2. That's not working. Let's see what that did for me. Just, yep, not what I wanted. Zoom out.
I just moved the zoom tracer.
Yeah, I didn't. Okay, we're gonna set a window that's a lot smaller.
Probably gonna drop one down on the y-axis.
Yep.
Use the maximum kind of power to line of sight with that.
Someone drew something like
Okay, so we get a much better illustration of the way that graph's pointed, because we're trying to figure out what the slope of that curve is right there at x equals 1. Okay. Basically, go to zoom in, and put your dot on the graph at x equals 1. And just keep zooming in until it looks like a straight line. Okay, that's what you want to do. Continue zooming in until it looks like a straight line. Does that look straight yet? No, it's still curved, isn't it? Anybody having trouble zooming in? You have to move the cursor. Yeah. And then you have to move it onto the graph, but you have to move it down. You probably have to move the cursor down or up, too.
Oh, you'll see we're in agreement.
Make sure you're in radians mode. Did you get it out, Allie Dovey? Did you get it? Alright, so, just, could I figure out the approximate slope of that curve? You can look at your window, do a slope calculation if you want to. It's good another way to check. So it's called local linearity. Okay. So just some tools for you to use this year. You're going to get better with those calculators. Some of you are pretty good already, but you're going to get better at them. Okay. Any questions? All right, let me throw it up. Yeah, probably. Just say it ain't so. It's pretty easy.
Just like the
Okay, there you go.